In our late-breaking work, Blended Interaction, Communication and Collaboration between two users across the reality-virtuality continuum, we investigated the communication of a virtual reality and an augmented reality user. This is an important task when users interact with each other within the same medium or when using different technologies. Example use cases are XR teaching scenarios or assisting first-time XR users when they have questions about the environment or controls. In our study, two users had to move a square-shaped object through a wall with a hole in the middle. To achieve this, the object had to be scaled and rotated in order to fit through the wall. In our setup, only the VR user could see the shape of the hole, but they were not able to rotate or scale the object themselves. This had to be done by the AR participant. Therefore, the VR user had to communicate the required shape to the AR user, who had to fulfill the request. In order to communicate, the users could use different methods depending on the condition: speech, visual widgets, or the combination of both. The widgets featured visual representations of scaling the object or rotating it around one of its three local axes. The VR participant could individually calibrate these widgets and send them to the other user. In a user study, we analyzed the communication and usability in the three different conditions, as well as the performance and preference of the users. We found that when using widgets and speech, exact requests like rotate the object by 20 degrees occurred significantly more often compared to the speech-only condition. Here, incremental requests like rotate it more occurred more often. Regarding performance, in the widgets-only condition, participants were significantly slower than in the two conditions where speech was allowed. No significant differences could be found in the number of collisions between the object and the wall. In contrast to this, the participants perceived the speech and widgets condition to be the fastest and the two conditions featuring widgets as the most precise ones. They also perceived the speech-only condition as the most joyful and would use the combination of both methods again for future tasks. Regarding usability, the participants gave both conditions featuring speech higher ratings than using the widgets only. To conclude, speech plays a fundamental role in XR communication, especially when body and gesture tracking is limited. For most cases, widgets should only be seen as an extension rather than a replacement of spoken language. While their usage slows down the communication process, they can help to make it clearer and avoid miscommunication. We believe that this knowledge can also be transferred to other technology combinations across the reality-virtuality continuum, and that this is an interesting area for future research.